Hi, so today we're going to find the sine, cosine, and tangent of 30 degrees and 60 degrees. So to do that, what I've done is I've set up an equilateral triangle, and then I've split it in half. And remember, an equilateral triangle, all the angles are 60 degrees. So if I split it in half, this top angle will become two 30-degree angles, since 30 is half of 60. And if I've split this in half and all the sides have length 2c, so I've made the sides all have length 2c, then this half of it would be c, and this half of this side would be c, since c plus c is 2c. Okay, so we have an equilateral triangle, and each side has length 2c. And we're going to call this height here a. And what we're going to do is we're going to solve for c using the Pythagorean theorem. So we'll solve for c in terms of a. So we get 2c squared, which is the hypotenuse, equals c squared plus a squared. So this is just coming from the Pythagorean theorem, and I've just used it on this triangle. So the hypotenuse is 2c. So if we use the Pythagorean theorem, we get 2c squared equals c squared plus a squared. And now I'm going to expand this side, so we get 4c squared equals c squared plus a squared. Because 2c all squared is 2 squared times c squared, which is 4c squared. And now I'm going to subtract c squared, so I get 3c squared is equal to a squared. I got c squared equals a squared divided by 3. And then I'm going to move it up here, that c equals a over the square root of 3. I just took the square root. So let me erase this now, since we've already solved for it. So you get c equals a over square root of 3. So I'm going to automatically replace this c with a over square root of 3. That means this would be 2a over square root of 3 because it's 2c, and this would still be a. So right now we've solved for c in terms of a. So now what we're going to do is find the trig ratios. So we're going to start with 30 degrees. So first we're going to find the sine of 30 degrees. So the sine of this 30 degree angle would be opposite, which is a divided by the square root of 3 over the hypotenuse, which is 2a over the square root of 3. So the square roots of 3 cancel. The a's cancel. So we basically got 1 up here. So we've got that the sine of 30 degrees equals 1/2. So the sine of 30 degrees equals 1/2. We just used the ratio, so opposite is a over square root of 3. Hypotenuse is 2a over square root of 3. And if we divide them, we get 1/2. So sine of 30 degrees equals 1/2. Now let's do cosine of 30 degrees. Well, that would be adjacent, which is a, over hypotenuse, which is 2a over the square root of 3. So adjacent over hypotenuse. So a over 2a over square root of 3. So a over 2a over square root of 3 is the same as a times the square root of 3 over 2a, because dividing a fraction is the same as multiplying by the reciprocal. So these two a's will cancel, and we get that the cosine of 30 degrees equals square root of 3 over 2. And now we have one more, which is tangent. So it's going to be adjacent, which is, it's opposite, which is a over the square root of 3 divided by adjacent, which is a. So a divided by the square root of 3 divided by a is the same as a over square root of 3 times 1 over a. So these two a's cancel, and we get that the tangent of 30 degrees is 1 over the square root of 3. So far we found the trig ratios for 30 degrees. So we found that sine of 30 degrees equals 1/2, cosine equals square root of 3 over 2, and tangent of 30 degrees equals 1 over the square root of 3. So that's how we find the trig functions for 30 degrees. And in the next video, I'm going to do the same technique to find it for 60 degrees. So remember, all I did was I used the Pythagorean theorem, solved for this c, and then I found the trig ratios by using what we've learned about opposite, adjacent, and hypotenuse. So for the sine of 30, I did opposite, which is a over the square root of 3 over here, over hypotenuse, which is 2a over square root of 3, and I got 1/2. Then I did the same thing for cosine and tangent, and I've gotten that stuff. So, hope you like this video.